Welcome to the second presentation to SUFOGIS students by Arbonaut Limited. I am Tuomo Kaurenne, the president of the company. And in this second presentation, I will briefly describe the kind of skills and technologies that Arbonaut as a company uses, and then after that analyze a little bit how that would reflect in the use of training that you get as students of forestry in different countries and universities, to try and see that what the job market today in international forestry would demand. And in particular, the climate-related part of that. So how do the market for carbon sinks, carbon markets, reflect on the skills needed by foresters in the modern world? Arbonaut was founded in 1994. I was the founding manager, and we currently have offices in Joensuu and Helsinki, and we've had an office in Stowe, Vermont in the US, which is right now dormant. On average, over the last 10 years, we've had roughly 45 employees, of whom 20 are foresters. Our turnover is about 20% annually, which is mostly related to the fact that we employ a lot of trainees and interns from universities, and some of them stay longer, others pass on with their careers. That's a deliberate policy. We want to be exposed to a lot of young graduates or students of forestry and geoinformatics, for example, in order to get fresh ideas into the company, and on the other end to have the capacity to expand whenever some parts of our business merits hiring new people. Arbonaut's core business is forest information and forest information systems. Arbonaut is mostly a forest and forestry company, although we have a very strong technology focus. So roughly 1/2 of our employees are either foresters or forestry students, including a few doctors of forestry. The other half, most of them are information technology specialists, software developers, but we also have a core team of roughly 5 mathematicians with unusually sophisticated skills in mathematical modeling. All of Arbonaut's business is based on research and development, and we conduct intensive collaboration with forest science at University of Eastern Finland, with mathematics and mathematicians at Lappeenranta University of Technology, and a lot of other universities, an issue that was discussed in the first presentation. Roughly 60% of our turnover has been generated outside Finland. Some of the recent projects we have conducted are shown on the following map. So in Northern Hemisphere, both Russia, Canada, Finland, Scandinavia, Poland, our activities are mostly related to harvestable forestry, so forestry for revenue and income from harvesting, whereas in the Southern Hemisphere, in Africa and South Asia, Southeast Asia, most of our projects are linked to climate change and climate mitigation activities. In Brazil and Peru and Uruguay, plantation forestry dominates. One of Arbonaut's biggest businesses historically, from 2007 to 2013, was power line safety assessment services, especially in the United States. This map shows the roughly 100,000 kilometers or 65,000 miles of transmission power lines that we cleared for falling trees. These were all high voltage power lines that had to be kept free from the danger of a tree falling and causing a short circuit and blackout after that. So that legislation was imposed in the US in 2005, and for the subsequent almost 10 years we were the market leader in providing these services. This was also based on airborne laser scanning, on which Argonaut mostly earns its revenue. So helicopters flew over transmission lines, and from the ensuing three-dimensional point cloud, we extracted trees that might pose a danger to the power lines in possibly breaking them. The biggest change in modern forestry, which is currently underway in many countries, is the digitalization of forest information. In the Finnish context, where we have started operations, this means the following. Increasingly, forest information is collected from the air, either by aircraft or by satellite. In Finland, the chosen technology is airborne laser scanning, or LiDAR, which is captured by aircraft flying at roughly 2 kilometers of height. So, data is produced from the air. However, in order to relate remote sensing data into practical forest operations, all these models have to be calibrated with real field data collected on the ground. In the past, it was necessary to visit every single forest stand in order to know what kind of trees, how much timber it would contain. Nowadays, only 100 to 1,000 times fewer field sample plots are needed, because they are only used to calibrate statistical models that are using airborne LiDAR information to correlate the point cloud statistics with the kind of timber beneath it. And this field collection will also find important biotopes and other valuable special targets that need to be singled out for specific treatment. Information invariably shared over the internet using either mobile services or possibly just on a browser, on desktop, whatever works best for the operational activity at hand. And beneath all this, there's one or more forest databases in which this information is managed, and at the same time its logical consistency is ascertained. So whenever some information is updated, it is made sure it doesn't contradict with some other information already in the database. So either the old information or the new information has to be matched against the background and appropriate corrections done so that a consistent forest database is retained all the time. Argonaut's primary products are called ArboGIS and ArboLiDAR. ArboLiDAR is a remote sensing based forest inventory service that is provided as a service, often on a project base. It has the benefits of accuracy, speed, and cost efficiency, especially related to the precision of the information and the efficiency of collecting. It requires LiDAR and aerial images as input data, and as an output produces forest stand borders and forest attribute information. There are some downsides, and maybe the most important is the fact that it is necessary to organize a flight campaign for this activity to succeed, and that means that because of the initial setup cost of such campaigns, normally the forest area to be mapped needs to be at least 50,000 hectares in size. ArboGIS is a geographic information system environment for forest analysis. It features tools for example, forest stand delineation, forest inventory, including field plot collection, Bayesian statistical analysis to calculate the inventory parameters, and producing all kinds of reports, both paper and digital ones, for forest operations such as harvesting, thinning, fertilizing, ditch construction, drainage construction, forest road construction, and so on. It interfaces to many spatial databases and can be integrated to complement existing geographical information system environments. We have used ArboGIS primarily for helping national forest authorities manage their forests, and we have done this, for example, in Finland, Russia, Vietnam, Pakistan, are in the process of doing so in Rwanda at the moment. The structure of the information system is often such that background fields are obtained from the most current and relevant sources, so either from national authorities who provide online maps, if possible, satellite imagery from satellite image providers, and then various vector datasets like roads and cadastre-like information whenever needed. The application itself then uses mathematical image processing to produce forest stands on which forest attributes are then calculated. So with such a background and such a business, what does a young forester need to know in order to work in a company such as Arbonaut? Here are some guidelines. First of all, there are a number of basic skills that nowadays are necessary in our line of business. Much of what we do is based on forest mensuration, so knowing that in theory and practice, especially with experience in forest field plot measurement, is important. Also, basic use and understanding of satellite imagery, aerial imagery, and using geographic information systems is universally needed. Open source geographic information systems are just fine, but also if you have experience on, for example, ArcGIS, that is helpful. We use all these technologies. In an international company and context, some language has to be the lingua franca, the language used for communication, and in our case, it's English. Although, as mentioned, we have 15 different nationalities on the payroll, and therefore on the order of 10 different language communities that are happy and free to use their own language in company internal discussions, and of course when dealing with customers from that language region. It goes without saying that the ability to work efficiently in a multicultural environment in many different countries is a must. So tolerance to different religions, races, all kinds of social statuses is quite important. You're valued as a human being, and your professional skill is your main contribution, and these are the only things that matter at Arbonaut. Then in terms of specialization, how would a forester be able to target her or his skills into a particular part of the aspect we do? So here I outline 2-3 different rather coherent skill sets that are focused a bit differently, but which all are needed in our forest profession. So the first one is combination of forest mensuration and software engineering. So if you have some studies in both, and I'm stressing here software engineering, it's just not programming, although that is helpful too, but knowing how to participate in software development projects, agile methodologies such as Scrum and so on, are quite important. This is how modern software is being produced by a team of IT specialists and also customer representatives and project managers that, in Arbonaut's case, almost all have a training as forester. The central task for a forester in these teams is to specify the functionality in new forest information systems. Often this comes in the form of a data model, but the crucial thing is to be able to specify very precisely what exact kind of information, attributes, records is needed in order for such information to be operationally useful. So you need to know what is it used for, but you also need to know exactly what kind of data represents that information. So let's say standwise basal area by tree species, various properties of stand borders, property boundaries and property hierarchy. This kind of thing all need to be coded in languages like XML, for example, or JSON. And therefore, that means that understanding what this means is important. So, this skill set requires a good understanding of work processes on plantations and in harvestable natural forests. Another new skill set is more related to conservation and multi-use of forests. So Argonaut, for example, provides the Finnish Forest and Park Service that looks after both the state harvestable forest, roughly 3 million hectares of that, and the national parks, which together comprise like 5 million hectares of conserved forest land. And in both cases, you need to understand why a particular action is relevant for the activity. So in terms of conservation, our focus is definitely now in the tropical and subtropical world, in developing countries and their forest markets, and therefore practical experience of forestry in areas or regions like Southeast Asia, Latin America, Russia, or Africa is appreciated. With this skill set, you should possess at least one of the following languages in addition to English. So, for example, Spanish, Russian, French, or Swahili as examples. Also Southeast Asian languages, Vietnamese, Laotian, Chinese obviously would be useful too. So here your main role is to understand how forests are being used and what is important for forestry in this corresponding geographic region, in conservation, but also in forest economy. The third new skill set is related to the climate market and especially to the Paris Climate Agreement, in which an agreement on the REDD+, so reduced emissions from deforestation and forest degradation program, was endorsed and accepted. And in this case, what is needed is quantitative measurement of the carbon sink provided by growing forests, and this results eventually in payment for ecosystem services. So for this large area forest mensuration skills, such as those relevant for national forest inventories and including management of field campaigns, is needed. But then you also need to know what do these climate-related legislation and protocols contain, such as the voluntary carbon standard, the Kyoto Protocol, the Clean Development Mechanism gold standard, and so on. So we need to provide information that meets the specifications of these standards. Satellite imagery is normally the means being used for this with limited field campaigns, but alone it will not be sufficient. You will need to know how to turn satellite imagery into trustworthy forest information. So altogether, please be brave. Forestry has never been as exciting as it is right now. So life as a student is wonderful because the world is full of new, exciting opportunities. However, life as a student is also hell, unfortunately, because often it seems that none of these opportunities seem to work for you. It simply happens to be so that there is hardly any tailored or targeted training for any of those skill sets that I was describing, so you end up assembling this knowledge and understanding from multiple sources, participating in a multinational forestry master's program, such as the one incorporated in SUFOGIS, is actually very useful. But you also could use remote education, special courses to educate yourself. Remember to be active, and then eventually you will find your niche in the forestry ecosystem. So just keep on trying. Thank you very much.